Siri, stop. Not feeling it. I need something else. All right. Welcome, scholars. Let's see, as far as announcements go. I just let whoever I just let into the Zoom call, there's one user whose name isn't showing, so I don't know who you are, so that means you didn't get attendance credit. You need to just send me a DM in the chat with your first and last name so I can give you attendance credit. Let me see. So, another vital piece of information. Exam 1 just became available 30 seconds ago, right? So exam 1 is available now for the next 7 days. So from today until next week, you can earn up to 100%. You get unlimited attempts on it, and the system is set to take your highest score. So what we will be doing this week, we're going to review and try to just review some of the concepts and some examples. So since exam 1 is over chapters 1 and 2, today we'll focus on chapter 1, and then on Wednesday we'll focus on chapter 2. As usual, if you have questions or concerns, feel free to unmute yourself to get my attention or type in the chat. I am monitoring the chat, and we can talk about it. If you've emailed me, like I know someone asked my instructor, it just totally slipped my mind. Don't hesitate to text me. Like that's why I put the office cell phone number there. That's going to get my attention a lot more than an email. I get like hundreds of emails every day. So, my emails, and I have it separated, Morehouse, Morris Brown, yada, yada, yada. But it just gets lost in the sauce. So for it to stand out, just send me a text to my office cell phone number, and you're good to go. Okay, so I just created a couple of assignments. It's practice not graded. You'll see it. So if we hop over to My Open Math, let me switch to view. Right here, right? So if we scroll down to week 6, we see exam 1 is available. There seems to be a prerequisite. Let's see what the prerequisite is. I can barely get that word out. The quizzes before you can attempt this exam. So you just have to submit them. Okay, so there is a prerequisite. You might need to pass those quizzes or something of that nature. But you can attempt it now. Also, as you make your way through the exam, if you get stuck on a question, you can ask me, right? You can screenshot and say, hey, Mr. Pfeiffer, can you help me with this? And then it just depends on how quickly I can get back to you, right? So just do what you need to do. Again, unlimited attempts. The system is set to take your highest score. You'll notice that the exam is going to be similar to the quizzes, but a little bit different, right? So you finish the exam, it should create a whole new exam every time you take it. The same content is still material from chapters 1 and 2, but every time you take it, it should be a completely different exam, right? So, That's kind of the long and short there. Okay, so just above, you'll see week 6 practice not graded exam 1 review chapter 1. That's what we're going to work on today. And it has like almost 150 questions. So I'm just going to jump around randomly. All right. I wish I had thought about this sooner. Like I could have had this up before, but I really just made it for class so we can have something to work on. Let me do something really quick. I'd like to hop over here. I think we do have some. Wait a minute. You have 2? No. Okay. So 2 and 3. Okay. And is that who again? There's still somebody that's Zoom user. So maybe they're still in the thing. So if your username says Zoom user, I still don't know who you are. I'm still looking for that DM for you with your first and last name, so I know who you are. Okay. Right here. Okay. Let me see. Let me update that. Right here, right there. Okay. Oh yeah, I wanted to change that setting right here. Okay. I'll do this for a little while until it gets on my nerves, and then I'll turn it off. That way I don't have people waiting in the waiting room so much. Was I working on right here? Okay. Give me a random number between 1 and, oh, that's not A. Between 1 and, I think it was like 143. Now, if that gets on my nerves, I'm gonna turn it off. Give me a random number between here. Okay. All right. We got a number. Let me get this student. So I could take attendance as you guys arrive, but I find that it can be this people coming and going. So that's why I usually do my 2 waves or whatever, but it's okay. I'm just trying something a little different just because. Okay, so the first question in our RNG, our random number generation, we got was 67. So let's give 67 a go. Okay. Let's see what we got. And you know what? I am going to try to do a poll. Now, this is a great opportunity. Yes, this is how I used to do it in the olden days. So let's hop over to Zoom right here. And we got this feature, if I can find it. Okay, polls and quizzes. I should have 2 ready to go. There we go. Let's launch. Okay. So there is a poll active, and let me show you how to use it, how we're going to do this. Let's go here. And let's put Zoom right there. I think that'll suffice. Okay, so for the question we have on the screen right now, there is a live poll. It's a good idea. It's a little bit extra work on my end. I think I can make it work a little bit quick though. But it's a good idea to engage. It says list. So this comes from section 1.4, question 29. This question asks us to list the points in the graph at which the function is not differentiable. All right. So in order for the function to be differentiable, it has to be a smooth, continuous curve with no sharp edges or breaks. So, okay, wait a minute. This isn't the right type of multiple choice because it's multiple answers. Okay, I'm gonna bypass on the poll, but I think you can put it in the chat. Any brave soul feel like they can get this correct in the chat? So what are the points? And I kind of need that to be visible. Let's go like this so we can zoom in a little bit better. Right? Yeah. Okay, I see X2 and X4. Let me see who this is. Okay, I got them. Let me just update this. Okay, we're looking good. So I see X2 and X4, right? There's one for that. Let's see, X2, X4. Okay. Where else? Let me see. Where else might it not be differentiable? So I think it has to be a smooth, unbroken curve. So the derivative, we say the derivative exists at a point if the limit from the left equals the limit from the right equals the value at the point. So I can get down with, I think x2 and x4 should be okay. Any others? All right. Okay. I'm going to give myself a whole bunch of homework. How do I do this? Okay, I see one for x1. I think x1 might be, x1, I see the asymptote. Yeah, right? I feel like it's not differentiable there. And there might be one more. Where else might it not be differentiable? So I think we said no sharp corners or edges. So I'm gonna throw in x3. Let me screenshot. I'll save that for later. I just got some homework I gotta do. Let's check. We got it. All right. All right. Let's do again. There is somebody in the call that's gonna look at the last time I said, so I know somebody's not getting attendance because your first and last name isn't showing. I know there's one person who says Zoom user, so I don't know who that is. So the next one, RNG, is question 110. So let's jump into question 110. Let's see if we can do a poll. Question 110. Okay. So this comes from section 1.6, question 61. It says the population P in thousands of a small city is given by the following function, where T is in time, where T is time in years. Answer parts A through C. So the growth rate, the rate of growth. So usually if it's a rate, what we're talking about the derivative. Find the rate of growth. I think I might just do this one. Can we just take the derivative quickly? Low D high, bottom times the derivative of the top minus the top times the derivative of the bottom squared. Given by the following functions T in time and years. Find the growth rate. Is that after 12 years? I'm feeling like we take the derivative. Let's see. I'm gonna view their example and match it up. All right. I'm thinking the derivative, right? Find the growth rate. So they did do the quotient rule. Okay. 400. Do we need to, maybe we need to just like write it out and we'll see it. Oh, that's a numerator and a denominator. Do they want all of that? Okay. Yeah, so basically for the first part, they're just asking us to find a derivative. I think I might try to do it here. If I need to, like, I'm going to get rid of Zoom for right now. So we're just taking a derivative with this guy. And it wouldn't hurt for you to try it on your own, to get some practice. Idealistically, I would have you guys take the derivative. Whoever does the most talking does the most learning, right? So idealistically, I would have you do it, but I think I'm going to just try this one. But you can try it on your own as well. So I'm going to apply the quotient rule, which is low D high minus high D low over low low. So it's the bottom. And I'm going to take my notes here if I can. So let me see. The bottom. You're not going to let me do it? Let's do per register. Okay. So the bottom is this guy. 2t squared, 2t squared. And if I need to write it out, I can. So low D high, the bottom times the derivative of the top, what is that, 400, minus the top, which is this, times the derivative of the bottom, looks like it's just 4t, all over the bottom squared. So I'm going to go like this. Then that's 2t squared plus 9. 2t squared plus 9. Okay. Now it looks like we can factor out a 400. We can't get anything to cancel. Can we get anything to cancel? If we factor out 400, we'll have what, 4t squared? So t. Okay, I think we can take it a little bit further. We can simplify it a little bit. All right. So for instance, if we factor out 400, okay, in the first term, we're going to be left with 2t squared plus 9. And then in the second term, we're going to say minus 4t squared, right? And then the bottom stays the same for right now. 2t squared plus 9 quantity squared. Okay. So now we factored out the 400. The 2t squared minus 4t squared is a negative 2t squared. Almost difference of squares. Yeah, I was kind of hoping that we can get something to cancel or simplify. So I think that the best that we can do on top, it looks like this 400 kind of lingers. Inside, we're going to have what, 9 minus 2t squared, 9 minus 2t squared. I think I got it. Let's go. There it is. If you work. And then on bottom, 2t squared plus 9. 2t squared plus 9. That's not a 9. Quantity squared. I think we're good. Okay. I can't get anything to cancel. I think that might be it. All right. Let me, I'm going to screenshot this. So just for my reference, there we go. I'll keep that for later. And I'm just going to get rid of my notes and just put the final result. Again, I wasn't able to get anything to cancel. I was kind of hoping that like something would cancel. That's always nice when that happens, but it doesn't always happen. Okay. So this is the result I got. And if that 2 weren't there, we almost had difference of squares. But I think I'm gonna go with this. Oh, they might want P prime of t. Click on view an example one more time. Continue. I just want to see, is that okay? That's similar to what we have. I'm gonna put P prime of t. Hopefully that'll minimize the chances of us getting it wrong. So P prime of t equals. Okay, let me check this guy real quick. I think that's, let me move this over. I feel like that's a little bit of a typo. That looks a little weird. Oh, no, I think it's fine. Okay, crossing our fingers. That's what we did. Let's just check it again. Okay, can I undo? That would be nice. Oh, I should have just copied it. I don't know what we did wrong. I don't think we did anything wrong. Only other difference, they distributed at 400. They got 9 times 4 is what, 3,600? And 800 here. That's the only 9 times 4, that was 400, right? That's the only thing I could see that's different than what they had versus what we have, unless we don't need the P prime of t. Let me try removing the P prime of t. Okay. Yeah, so I think we just didn't need the P prime of t. I think even what we had before would have been fine because it's the same thing, right? So, but again, with that part A, all we did was the quotient rule. Low D high minus high D low over low low. If I need to write out those details, just let me know. Again, this is recorded, right? So you could always pull the recording. You see the change that we made. We removed the P prime of t. Find the population after 11 years. The population is blank after 11 years. So then we have a population formula. We can just plug that 11 into the population formula, okay? So what I'm going to do is break out my trusted dusted raster. Come on. Right here. Where is it? This one. Oh no, right here. Okay. All right. Oh, we need the formula. So I'm just going to put that into my y equals. Let's reload and refresh. Come on. So I'm going to go to y equals, let's do parentheses 400x, close parentheses, divided by 2x squared plus 9. Okay. So that's the population model. And then we want to evaluate this guy when t is 11. Okay. If you need to see the details on how I'm pulling up the function, just let me know and I'll slow down what I just typed in. So if we evaluate this when t is 11, let's see, it says round to the nearest integer, so 18. Wait a minute. Thousands, so 18,000. So then 17,530, I think it's 530, right? Because this is in thousands, so 17,530 people. I guess so, yeah. Seems like a small town. Okay. All right. Find the growth rate at 11 years. So we want to basically plug 11 into the derivative that we found. And I think that, when we were working through the homework or the classwork, we discovered how to evaluate a derivative here, right? So if I go to math, I forget where it is though. I do have to find it. I think it was probability. Here it is, number 8. So in derivative, we want to call on that function, right? I'll get them in just a moment. We want to evaluate this function when we want to take the derivative of this function with respect to x and evaluate it when x is 11. Right? This is how we type it in. So this one, I don't think it can like find the derivative, but it can evaluate the derivative at a value, right? So like so this is the population is decreasing, and that's what the image says. So yeah, that makes sense. The growth rate is decreasing, nearest integer as needed, residents per year. So this is based on thousands to the nearest integer. So it's decreasing by 1,479 people per year, residents per year. Let's see. Let's do a negative 1479. 1479. Let's see. Cross our fingers. Nice. It was fun. I know we just got somebody in the Zoom call. I was kind of hoping that we could do polls, but this is fine. Some of these, they can be a bit much. Let me get the student. Ford. Let's see. I got it here, right there. Okay, I think we're looking good. All right, so let's do another RNG. Generate. Let's go to question 22. All right. So question 22 is here. Okay. So use the theorem on limits of rational functions to find out the following limit. Okay. So the limit as x approaches -2. So I think we could just evaluate this if we just plug in -2. That's going to be 4 minus 6 is ultimately -2. Right? If we just plug in -2, we get a result of -2. So yeah, I'm just going to plug in -2. Also, if you think about it, this is what a parabola that's moved down by 6 units. So as x approaches -2, right? There's nothing funny going on. The left-hand limit equals the right-hand limit equals the value at the point. Or the left-hand limit equals the right-hand limit. So this should be good. There was, let's just kind of see if we can, what else we can kind of come across. Let's generate another RNG. We're going to go to question 121. Come on, a little further. Right there. All right, let's look at question 121. Differentiate this function. I think I will take notes. We got to use the chain rule and the quotient rule. I think I'm going to write this one out. This one looks like I need to write it out. So, yeah, just for the sake of time, I started to pass it off to you guys, and there's nothing stopping you from like working it, especially if this is like throwing a tantrum. You can like, if you want to get started, screenshot it and give it a go. I just want to copy. No, that's not what we're doing. Done. Copy and delete. I'm going to paste it right here. Paste. Come on. There you go. You gotta talk stupid, it'll be like, your wish is my command, and it'll start acting even more dumb, right? So you got to be like, hello, Bessie, you can do it. You got to talk to the general. Okay. Oh, where I'm looking for this guy. All right. So we got a couple of rules at play here, right? The first rule that I see is the chain rule. So we got the derivative of the outside times the derivative of the inside. And then when we do the derivative of the inside function, it looks like we need to use the quotient rule, right? Okay, come on, right here. There we go. So when we go to take the derivative, right, that means we're doing d by dx of, now I'm going to rewrite the original. Instead of writing it as a square root, we want to change that square root to a rational power or a rational exponent. Plus x over 1 minus x. And we're going to say what? To the power of, so square root is the same as to the power of a half, right? So now when we go to take the derivative, I see that's exactly why I have the thing off. When people start leaving, hang on. Yeah, it just distracts me. Right here. There we go. I'm done. All right, cool. Right here. Okay. So when we go to take the derivative, what? The power comes down and we subtract one. Okay. And then we're going to say times the derivative of the inside function. Okay. So then we get the 1/2 4 plus x over 1 minus x to the power of a negative 1/2. And then we say times. Now the derivative of the inside function, we got to do the quotient rule. Low d high minus high d low over low low. So low is this guy. D high, what is that, 1? So I'm not going to write anything. Low d high minus high d low, looks like it's a negative 1, all over low low. All right, it sounds silly, but that's just how I remember it, right? Okay. So we got a double negative becomes positive at play here. We can combine like terms. Now it looks like when we combine like terms, this guy is going to be canceled by this guy. And it looks like we're going to be left with 5 on top. Okay, let me put all this together. So since that's to a negative power, that's in the denominator, we have this 4 plus x over 1 minus x. Let me see. That's going to be a times 2. And we also have this 1 minus x squared. We might be able to rationalize that. Right now, we're looking like this. Those are all the things on top. It looks like the only thing on the here is the 5. I'm really tempted to rationalize this guy. Let's rationalize and see what happens. So if we multiply by 1, I'm going to multiply by 1 in the form of 4 plus x over 1 minus x. In this form, 4 plus x, 1 minus x. All right, so multiplying by 1 doesn't change it. But what that allows us to happen is this radical cancels that one, right? So, okay, I feel like I need to rewrite it. So that's going to be to the power of 1. That's going to cancel one of these guys. Okay. So now at this point, it looks like we still have the 2, we still have the 4 plus x, and we still have the 1 minus x. But on top, we got all of that. Can we break that apart? Will that help us? So what I want to break apart the other piece, right? So we have this 5, and I probably could have done this sooner and it would have helped. I kind of want to go back, but I'm not going to. I'm going to just go ahead and try to finish this. So 5 squared plus x. And, if we break it apart, then we still have another 1 minus x here. And this is probably what I should have done sooner, broken apart earlier. Let me rationalize one more time, because I'm trying to get rid of the radical denominator, just see if anything cancels. 1 minus x, 1 minus x, right? So these radicals are gone. Now on bottom, it looks like we have the 1 minus x squared. So it looks like we have the 4 plus x, 1 minus x squared, 2. That doesn't really look like it helps us either. I don't know if it's going to take this answer. 5 times the square root of 4 plus x times 1 minus x. And we could probably expand that, but nothing cancels. Let me see. If that's to the power of half, a half minus 2 is a negative 3 halves, so 1.5. I think this is about the best we can do. Let me try this result, or before, actually, so I don't waste one of my chances, to minimize my chances, let me move this over to the side, and I'm gonna compare it to the viewing example. I don't want a new one. Okay, hang on. Let me get rid of this. Close. Let's go here. Site. Let me just slide this over here because I just want to see what format they put in. Let's say view an example. And let me see. We did that. We probably should have. In hindsight, I wish I had split it apart. I think that would have made things a little bit easier. They did do the chain rule. That's fine. We did all this. I think we got that. 9 minus x to the 3 halves. Okay. A half minus 1 is a negative half. A half minus 2 is a negative 3 halves. Okay, I see what they did. Yeah. So, but I mean, it's fine. It's now at this point, it's just like semantics. It's like, okay, what form do you want it in? We rationalized ours, so we didn't have any radicals in the denominator. I think they got theirs in like lowest power form or something like that. All right, so I'm gonna match theirs. Right, I'm just gonna match their format, and basically, where we have the square root of 4 plus x, that's to the power of a half. The denominator is to the power of a 1. So a half minus 1 gives you a negative half. That's where that first term comes from. The second term, a half minus 2 is a negative 3 halves, and that's where that second one comes from. So I'm going to put ours in their format, right? So I think we got it. So let's see. Now they had a negative. Should we have a negative? I don't think. Let me check one more time. Yeah, nope. Because that was a double negative was positive. 1 plus 4 is a positive 5. We don't have a negative. I don't see it anywhere. So I'm going to try it. I hope it's not a negative in there. It's really going to irk me if it is. Now on top, there's a 5. On bottom, we got this 2, 4 plus x to the power of a half. And then times 1 minus x. Oh, now they probably factored it out of there somehow. Anywho, times 1 minus x, and that's going to be to the power of 3 halves. Okay, that's about the best we can do. All right, let's give it a go. God is good. All right, look at God. All right, okay. So, unlimited attempts, do what you need to do. It's okay. But, come on. Oh, come on. Thank you. Let's do another one. 91. Let's go to question 91. Let's get rid of this for right now. It's kind of hopeful we could do polls, but that's okay. Question 91 is here. Okay. It says this equation can be used to determine the heart rate of a person whose heart pumps 6,600 milliliters of blood per minute and V milliliters of blood per beat. Let's see. Oh, V, okay, milliliters of blood per per beat. Complete parts A through C below. Find the rate of change of the heart rate with respect to V, the output per beat. So yeah, just take the derivative. I would like to rewrite that original as 6600 V to the -1. Like if whenever possible, I personally just avoid using the quotient rule. I feel like the quotient rule is a little bit more challenging whenever I can. Like we don't always have the luxury of avoiding it. Like this one, you can rewrite it, right? So like for instance, I think I can do it here, 6600 V to the power of -1. So then when we take the derivative, the -1 comes down, 6600, now it's going to be V to the power of -2. So then if we write it with a positive power, that's going to be a negative 6600 over V squared. Nope, V squared, all right? I feel like this is okay. All right, let's go with this. Okay. So find the heart rate, the rate of change of the heart rate. Find the heart rate at V equals 60 milliliters per beat. Okay. So I think we just plug in 60 into the original. So 110 beats per minute. I think that's 110. If we just plug 60 into the original function, okay. And then find the rate of change at V equals 60 milliliters per beat. So then we plug the 60 into the derivative. So 3600. So it's really 66 divided by 36. Siri, what's 66 divided by 36?
66 divided by 36 is approximately 1.8333.
It sounds like it's 1.83 bar. So 1.833 negative. Okay, let's get rid of this. Negative 1.83. I think that's good. Okay. All right, let's generate 101. Okay, so this is basically like all of chapter 1, and I'm just trying to cover as many concepts as I can. Differentiate. So I don't think we can like rewrite this one. We just need to just do the derivative. The first, and it looks like a twofer, right? Where the first part we need to do the quotient rule, and then the second part is just like the power rule, right? Simple derivative. So I'm going to take some notes on this one. I'm going to get a copy. Okay. Let's copy and delete. Come on. Paste. Yes, right here. Allow the paste. God is good. All right. Come on. So this comes from section 1.6, question 27. And we're asked to differentiate. Okay. Let's see. Okay. So then our G prime, so if we do low D high, low is this guy. D high is going to be this. Minus high, which is this guy. D low is this. All over low low. Okay. And then plus the derivative of the second term is this. Okay. I don't see anything that factors, but we can like simplify, combine like terms and simplify. What is that? 24 plus 18, negative 24, positive 20. Okay. that's gonna be too much to combine that. This guy cancels this guy. 38. Now, I mean, we could combine this into one term if we multiply by 1, but I'm gonna see if they'll accept it like this, like if this is far enough. So what do we do? View an example. Come on. My device decides to work today. I guess I gotta unplug it. I hate to refresh it. It's not registering anything. It's registering that. Well, if I refresh it, we're gonna lose our work. Okay, that's working. Okay. All right, there we go. I just want to see how they put what form did they put the final answer in, because we might need to go a little further. And I might just be being lazy. Keep going. I just want to see what form they put theirs. Oh, let's keep going. Okay, cool. Yes. Okay. Good. Okay. So with ours looks similar, right? So that's a good omen. Cool. So the numerator looks like we got was 38. What is that? A 4x plus 3 squared. 4x plus 3 quantity squared. And then plus 3x squared. Okay. All right, let's generate. We got 70. Right here, 70. All right, so this comes from section 1.4, question 48. It says find G prime chain rule, right? Let's just do it here. So if we apply the chain rule, the power comes down. So we're going to say times a half. And then we still have this 14x, but then that's going to be to the power of a negative 1/2, okay? But then we need to say times the derivative of the inside function. So that's just going to be 14. So then 14 divided by 2 is a 7. So it looks like we're going to have 7 over the square root of 14x. And that should be good. We shouldn't have to rationalize that. We can if we need to. I feel pretty confident in this. I'm going to go with this. Okay, let's go ahead and do another one. Generate. 39. I feel like there should be questions, but, and these questions can be a little bit, Okay, let's give this one a go. It says, on a hill, there was a hole 4 feet deep. Let me see, on a hill, there is a hole 4 feet deep. Let me see, okay. The function h of x graph to the right gives the topological elevation above sea level. Okay. For example, h of 3 equals 1 indicates that the bottom of the hole is 1 foot above sea level. I see. So when x is 3, the depth of the hole, the bottom of the hole is 1 foot above sea level. Okay. The function h of x can be modeled by this formula. The height above sea level is going to be 1 when x is 3. Otherwise, it's this other one when x is not 3. So I guess that might be like the equation of the hill. It looks like that factors. Does that factor? Is it 3 and 2, like x minus 3 times x plus 2? It's basically x, I think like a x plus 2. Okay. So find the limit as x approaches 3 from the left. Okay. Select. So basically, I think coming from the left, we're going to be in that second row. If we try to just plug in 3, I think we get 0/0. Yeah. But if we simplify, right, if we factor that numerator, I think the numerator factors into x minus 3 times x plus 2. The x minus 3 is canceled. So all that we're left with is x plus 2. So then when we plug 3 into x plus 2, then we get 5. All right. And that's pretty much where the line, like at the top of the hole is, right? Yeah, I think it's 5, right? So we're gonna go 5 here. The left-hand limit equals the right-hand limit. Okay. So interpret the limit as x approaches 3 from the left of this function equals 5. As you approach the hole from the left, your elevation nears, it should be 5 feet above sea level. There it is, part C, right? As you approach the hole from the left, your elevation nears 5 feet above sea level. So let's go with C. And then it should be the same thing from the right, because this is line. So 5. Okay. And then that one looks like D. As you approach the hole from the right, your elevation nears 5 feet above sea level. That's an interesting example. Question. So then it's just going to be 5 because, so the limit as x approaches 3, because the left-hand limit exists and the right-hand limit exists, and those two limits are equal to each other, then the limit is as x approaches 3 is 5, right? And then, that's enough. There's a little bit more I want to say there, but okay. So as you approach from the left or the right, your elevation there is 5 feet above sea level. All right, we're gonna go with B. Okay, that one was fun. Oh, find the limit as x approaches 3 algebraically. Begin by factoring the numerator, right? So we said that was x plus 2. So I think this is the way we did it. We did it algebraically first. If we can get this to work. All right, let's get rid of U. Oh, almost had it. I'm rushing a little bit. X plus 2, right? X plus 2. Nope. More. Plus 2. Okay. We got like about another little over. It's really closer to 30 minutes, but I'll probably keep it to 20 minutes. Let me check on Zoom. Check on you guys here. Let me get this student. Right here. And let me check the chat. Yeah. Yeah. It's nothing I can do about the quality of it. I don't know, because like I have good internet or decent internet. I don't know if it's just too much stuff on the internet. Maybe might need a signal booster or something. I saw I couldn't move to a different part of the house as well, but I saw this like little clip today that was like, if you need to do a makeshift Wi-Fi signal boost, you can take like a piece of cardboard and cover it in aluminum, and then kind of make it like a slightly curved standing wall, like it's almost like a satellite dish. You put it behind the router, and it'll direct the signals in whatever direction you want it to. But that just kind of made me a little bit nervous. I was like, you know, we got signals everywhere, and we're surrounded by this stuff, but that's why it's important to get outside and ground and stuff like that. So then the x minus 3 is canceled here. So then we should have x plus 2. There we go. X plus 2. Why is it not registering the plus? Plus 2. Okay. Then there's another part. And then that's where the 5 comes from. Okay. All right, let me check the Zoom one more time. I think you guys look good. Okay. Let's keep going here. And let's generate. 86. Question 86. All right here. For this function, find the points on the graph for which a tangent line is horizontal, right? So the points on the graph where the tangent line is horizontal, that means it's going to have a slope of 0. So that's where the derivative is going to be 0, right? So if we take the derivative of this guy, you can quickly find it. The derivative is going to be 2x. So then when is 2x going to be equal to 0? I guess at the origin, right? When x is 0, right? So when x is 0, the corresponding y is -6. So then the tangent line is going to occur at 0, -6. I guess it's the vertex of the parabola, right? So 0, -6. Type in the order pairs, we just got 0, -6. Okay. That came from section 1.5, question 62. Let's go to question 11. Okay. Here we're asked to graph the function and then find the specified limits. If necessary, state that the limit does not exist. So we're given this absolute value function. Let me zoom in a little bit. So we're given this absolute value function. We're asked to find the limit as x approaches 2 from the left. And no, sorry. The limit as x approaches -2, and the limit as x approach is -4. Where does this vertex occur? What are the transformations? Let me see. Do we move it left by 6? So that causes a vertical stretch. Let me see if I factor out. If I factor out 3, you'll have what, x plus 2? So when x is -2. Okay, so when x is -2, it looks like the vertex is, we get a result of 0. Where's our 0? When did we move it? I don't think we moved it up and down. We just did horizontal manipulations. So it looks like the vertex should occur at -2. Okay. All right. So if that vertex occurs when x is -2, remember the derivative, we can't talk about the derivative at like a sharp corner, right? So if we want, because like if we take the limit as it comes from the left, right, we probably more than likely will get a negative result. And then we take the limit coming from the right, we'll get a positive result. So then the left-hand limit won't equal the right-hand limit. Absolute value, we can break it into a piecewise function, right? So f of x equals here. I mean, I'm trying to think of the simplest way to do it. We could break it into a piecewise function. You could also look at the graph. Let me see. So let's start by looking at the graph because that's what they want us to do. So we're going to go ahead and graph this guy, absolute value. I'm just clicking randomly. Okay. So I'm going to have to move these points. So I think when x is -2, we're on the x-axis. So I'm just going to drag that point into place. And then I'm going to evaluate it when x is 0. Right? When x is 0, we're at 6. So I'm just going to move the second point to 6. I feel like that's good. Let's just choose a few more test points to just make sure it's working properly. For instance, when x is 1, it's like we should be at 9, and we are. When x is at -1, looks like we should be at 3, and we are, right? When x is at -3, we should be at 3. -9 plus 6 is D +3, okay? So this graph looks good. I'm gonna hit save. I just, you know, first I plotted the vertex, then I plotted an additional point, and then I just checked a few points to make sure that the function matches the graph. Okay, I'm gonna hit check the answer. Okay, now the limit as x approaches -2, right? So coming from the left, it's gonna have a slope of, looks like it's a -3. But again, because it's a sharp corner, the limit does not exist, right? So we can just use that. Oh, did we get it wrong? Select the limit as x approaches -2. Because one is negative and one is positive. Is there another option? Let me see. How is that? How is that not the case? -4 is there. That would make sense. Hmm. I'm going to review an example because that should be B. Coming from, and it doesn't say like the left or the right. Let me see. I don't know why I marked that one wrong. That one should be the limit as x approaches 4, right? So coming from the, let me see, from the, that's approaching from the left. Are they both approaching 0? Hmm. Okay, I guess it's 0. Hmm. Oh, you know what? I think I'm thinking of the derivative. I think that's why that didn't work. The derivative we can't take at a sharp corner, right? But the limit from the left equals the limit from the right, so that's why we could do that one. Okay. So yeah, that definitely missed that one. I think I was stuck on derivative, right? Coming from the left, the y value is approaching 0. Coming from the right, the y value is approaching 0. So then that limit is 0, but it's not defined at that point, or it's not differentiable at that point. The limit as x approaches -4 looks like it's 6. Okay, so let's go with that. Okay, so we missed that one a little bit, but it wasn't too bad. All right. Okay, let's do like I think we have time for like maybe 1 or 2 more. Oh, let's see. Generate. Let's check question 77. Right here. Okay, the derivative, so we can use the power rule. The power comes down, so 0.7x to the power of a -0.3. Oh, okay, let's do another one, generate. Let's go to question 27. Okay. Okay, let's take some notes on this one. This one might be our last one. It just depends on how it goes. Let me get a copy of it. Thank you. You were actually working today. Okay. Let's copy and delete. Out here. Come on. Come on. Thank you. Paste. All right. Simplify the function algebraically and find the limit. Okay, so first it asks us to simplify it algebraically, right? So we have the limit as x approaches 3. On bottom, we have x squared minus 6x plus 9. On top, we have x squared plus 2x minus 15. So we might be able to factor. Let's see if we can factor these guys into some form like this. Okay. If I work with the bottom, they're the same and they're both minus. They're opposite here. So one's plus and one's minus. Okay. On bottom, two numbers that multiply to give us 9 and add to give us 6. Looks like it's 3 and 3. 15 would be a positive 5 and a negative 3. Okay. So I think we need to put a disclaimer and say that what x cannot be 3, even though we cancel this guy. Okay. So we need to keep that in mind, that x can't be equal to 3. But we can talk about what happens on the left and the right. Let's see. Looks like it's a vertical asymptote. It looks like it goes to like infinity. Okay. Trying to think of a simple way. All right, so yeah, I have a plan. Let's see. Let's go back here. Say it does not exist. So I don't think it approaches a number. I'm gonna go with this one. I kind of want to do one more. Let's do one more. Just because we can. Oh, come on. Generate 43. This will be our official last one for this chapter. 43 is here. Okay. So it says, state the average rate of change for the situation. Be sure to include units. Chris grew from 151 centimeters at age 13 to 180 at age 17. Okay. Centimeters per year. Okay. So then if we say 180 minus 151 is what, 29? So 29 over 4? That's 29. Let's do 29 over 4. Centimeters per year. Wait, wait. So it should be centimeters per year. Yeah, there it is. All right, gentlemen. So I need to skedaddle. So again, I feel like there should be questions, but I totally understand if you don't.
I got a
That's the best time
question.
to ask. Yes.
So how did you get 29 over 4?
Okay. Let's see. So rate of change, right? So I just basically found the slope between the 2 points. Y2 minus Y1 over X2 minus X1. Right? So I said 180 minus 151 over 17 minus 13. Okay.
Oh, okay, I get it.
Yeah, so worries. Yeah, here. Let me make a copy available to box. Let me put it in the correct folder. Spring, traditional, calculus, notes, updated daily. So you can get a copy of anything that you saw me writing once this bar finishes loading. And then, the recording is available. I do need to go and like organize my videos. They're all there in the live section for our course. I just need to like, put thumbnails and a description. I mean, I could do it quickly. I don't know. I just been distracted. Are there any other burning questions before we go our separate ways, gentlemen? Going once, going twice. Forever hold your P's in race. Okay. So again, exam 1 is available now. You get unlimited attempts. So for the next 7 days, you can earn up to 100%. Right. Unlimited attempts. The system is set to take your highest score. You can actually submit the exam past the due date, which is like basically a week from today. But then there's like a 5% late penalty. So if you submit it late, the highest you're going to earn is a 95%, which is still, in my opinion, still pretty good. You should notice when you're taking the exam, it'll change, right? I don't know how many questions, maybe 20, maybe. I'm not really sure. But, if you get a score, you go to take it again, it'll be a completely different exam. Same, it's still covering chapters 1 and 2, just a new set of questions, right? And it should change every time you take it. So, okay. If there aren't any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your evening, get some good food, get some rest. And then, again, my favorite time to study is I usually wake up at like 2, 3, 4 in the morning, just naturally. That's when I do most of my work, like in the middle of the night. But, I don't know you guys' schedule. I know you got to be someplace early, so what's best for you. But again, so yeah, we'll go ahead and end the session here, and we'll meet back on Wednesday, same time, same place. So we'll talk about chapter 2. All right, gentlemen, take care. Enjoy your evening. Peace. It would be nice if that worked. It's too much like right, but that's okay. All right.